is new. Just so you know, this is a channel that gives detailed descriptions and step-by-step solutions on a variety of important topics. If you have not already, please hit that subscribe button to stay up to date with our videos and keep on learning something new. It really helps the channel make videos frequently and is completely free. Also, please comment down below if you have any questions or if you want me to cover a specific topic. Thanks, and let's begin with today's topic. So first, we're going to focus on the different properties you use in Algebra 1. So first, we will look at the commutative property. This basically shows that no matter how you add or multiply a number, you will always get the same answer. So as you can see here, a plus b is equal to b plus a, and it doesn't matter where the b is or where the a is, they will always equal the same answer. And this is similar to the multiplication version of this, where you have a times b is equal to b times a, where the b is the first term, but the a is the first term here, but they equal the same answer. So here we have examples, and one is the addition version and one is the multiplication version. So we can see here how both the 4 plus 3 is equal to the 3 plus 4. When we add 4 plus 3, we get 7. And then when we add 3 plus 4, we also get 7. So as you can see, these two are equal, which shows that the addition commutative property makes sense and works. Now we can look at the multiplication version. So we have 3 times 2, and that is 6. Now let's see if 2 times 3 is, and that is also equal to 6. So as you can see, these two are equal and the multiplication version works. So now we have the associative property, and this shows that you can group numbers in any way and still get the same answer. So as you can see, b plus c is grouped together and added to the a, and that is equal to how a plus b is grouped together and added to c. So as you can see that they equal the same thing. And that is similar to the multiplication version where b times c is grouped and then multiplied by a, and that is the equal to a times b, which is grouped together and multiplied by c. So as you can see, this shows that no matter how you group numbers, you will always get the same answer if it's in addition or multiplication. So here are a few examples so we can look at it. So we'll work on solving the equations and seeing if it's equal. So you have 6 plus, and you do the parentheses first, and we get 9 plus 3, which is 12, is equal to, and then we do the parentheses first, 6 plus 3, which is 9, plus 9. Now let's see if that's equal. 6 plus 12 is 18, and 9 plus 9 is 18. So as you can see here, both of them are equal, so they worked out. Now let's look at the multiplication version. So we have 4 times, we do 2 times 3 first, which is 6. And then we'll do the parentheses first here, which is 4 times 2, which is 8. And then multiplied by 3. Now let's see, 4 times 6 is 24. And 8 times 3 is 24. And as you can see, this also worked out and they are equal. Finally, we have the distributive property, and this property is like solving an equation. Now this is similar to a concept that we'll learn later on called the FOIL method, and it really helps with that. So let's see how you can do this. So the distributive property basically says that you have to take the a when it's multiplied by two numbers in parentheses that are added together. You take the a and multiply it to the b, and you also multiply it to the c. So that way you have a times b together plus, because this plus sign doesn't disappear, a times c, since you distributed it to both numbers. So now let's take a look at an example. We have 6 times 3 plus 2. And we can look at this by using the distributive property and distributing the 6 to the 3 and the 6 to the 2. Now we can write it as 6 times 3 plus, because you keep this plus sign, 6 times 2 since you distributed to the 3 and the 2. Then you get 18 since 6 times 3 is 18 plus 6 times 2 is 12. And then finally you get 18 plus 12, which is 30. So that will be your answer for this equation. Now to check this is to check it to make sure that you did everything right. You can solve this another way where we have 6 times, and you do the parentheses first because of PEMDAS, and you get 6 times and then 3 plus 2, which is 5, and you get 30. So as you can see here, the distributive property worked and you got the same answer and it got distributed properly. So here I have two properties that are very useful. So the first one is the additive inverse property. So this property we see a lot, and so what you're going to do is you create a subtraction problem when you have a regular number and an integer added together. So as you can see here, a is added to negative a. So you can rewrite this and write it as a minus a and then equals 0, since that is a minus a. And as you can see, you can take the integer and create a whole subtraction problem. So we'll look at an example. So we have 7 plus negative 7. Now we can rewrite this as 7 minus 7, since we take the negative sign and take it out, and then we get 0 as the answer because 7 minus 7 is 0. So the second property that is very useful to know is the multiplicative inverse property, which is basically if you have a times 1 over a, it will be equal to 1. So if you can see here, you can create a cross multiplication problem to see this property in use. So we'll have a, and then we can write over 1, since a over 1 is just a, times 1 over a, and we get, you can cross the a's out, and you get 1 times 1, which is basically 1, and as you can see here, this worked out. So now, the reason that it is where a is not equal to 0 is because 1 over 0 is an undefined and not true. So as you can see here, we have an example, and we have 6 times 1 over 6. We can create a multiplication, cross multiplication problem. 6 times 1 over 6. We can cross the 6's out, and as you can see, we got 1, which is correct. So now we have to understand how to use these three main properties in an algebra context. So as you can see here, I have provided an example for each of the properties in an algebra context so you can understand it better and in use. So as you can see, first, it's a distributive property. So as we learned, we take the 7 and we have to distribute it to the inside terms. So we distribute it to the x and to the 4. So then we get 7x, and you have to always remember this minus sign. So we'll keep it in the middle, and we have minus, and then 7 times 4. Now that is equal to 7x minus 28, since we just multiplied 7 by 4, and that is our answer. So as you can see, this is how we use distributive property. Now let's take a look at the associative property. So the associative property says no matter how you group it, you will always get the same answer as if it was grouped right now. So as you can see here, we have 6 times, in parentheses, 1 over 6 times 7. Now, this can create really confusing fractions for some people, so it's really easy just to group numbers differently. So as you can see here, we can group the numbers as 6 times 1 over 6 times 7, and then that will be your answer. Because we don't want to deal with this ugly fraction, 7 over 6. We just want a nice easy fraction. Nice easy solution, sorry. So we can divide by 6 and we get 1. So we get 1 times 7 and we get 7 as our answer. So as you can see here, we use associative property in an algebra context. Now finally, we have the commutative property, and that is you can rearrange the numbers and it will always equal the same answer. So as you can see here, we have negative x plus 3x. Now that sounds really confusing, so we can rearrange it and take this side of the x, and we'll do 3x minus x equals 10. I just switched the places of these two, and that is allowed because of the commutative property. And we get 2x equals 10, and finally we get x equals 5 as our final answer. So this is how you use the 3 main properties, as you can see here, in their algebra forms. So this is all we have for today for this topic, so hopefully you guys learned something new or got a refresher out of this. If this helped, please subscribe and like the video for more. Thank you and have a wonderful day.